On June 13, 1983, a silent gold anodized aluminum plaque aboard a small boxy spacecraft named Pioneer 10 crossed a threshold that, at the time, didn't officially exist. As the probe passed the orbit of Neptune, it was entering a realm that the greatest minds in astronomy believed was a desolate, empty void. For decades, the maps of our solar system simply stopped at the 8th planet, ending in a clean, black finality. We believed we were looking at the edge of the world, a cosmic shoreline where the sun's influence simply faded into the nothingness of the interstellar dark. But Pioneer 10 wasn't crossing into a vacuum. It was sailing headfirst into a ghost kingdom, a massive swirling archive of ice and stone that had been waiting in the shadows for 4.5 billion years. This is the Kuiper Belt, a gargantuan ring of frozen debris that encircles our sun. But to call it a belt is almost a disservice. It is a structure so vast, it is 20 times wider and up to 200 times more massive than the asteroid belt we're familiar with between Mars and Jupiter. And yet, for the better part of a century, it remained the solar system's greatest ghost. Even Gerard Kuiper, the man whose name is forever etched into this region of space, didn't actually believe it was still there. In 1951, he calculated that the gravity of a massive Pluto would have long ago cleared the region, scattering its residents into the far-flung Oort cloud or ejecting them into the galaxy. He did the math perfectly, but he did it with the wrong numbers. He assumed Pluto was the size of the Earth. It wasn't until the discovery of its moon, Charon, in 1978, that we realized Pluto was a tiny fraction of Earth's mass, less than 1%. The belt existed only because Pluto was too small to destroy it. For years, we lived in a solar system that felt finished, a clockwork machine of 9 planets. But as our technology sharpened, the void began to speak. In 1992, after 5 years of staring into the darkness from the summit of Mauna Kea, astronomers David Jewett and Jane Liu spotted a faint reddish speck 44 times farther from the sun than the Earth. They wanted to name it Smiley, but the history books recorded it as 1992 QB1. It was the first trans-Neptunian object ever discovered, and it shattered our understanding of the solar system's architecture overnight. Suddenly, the edge wasn't a line anymore. It was a question mark. Today, we know of over 2,000 objects lurking in this twilight zone, but models suggest there are millions more, ranging from tiny ice grains to dwarf planets the size of continents. But here is where the story takes a turn into the truly bizarre. When we look at the Kuiper Belt, we aren't just looking at a ring of rocks, we are looking at a cosmic archive, a recorder of catastrophes. This region is a natural time capsule, preserved in a deep freeze that has remained unchanged since the birth of our sun. On Earth, the wind, the rain, and the shifting of tectonic plates erase the history of our planet every few million years. But out there, in the negative 220 degrees Celsius dark, every impact, every gravitational nudge, and every chemical fingerprint is frozen in place. However, as we've begun to weigh this structure, we've run into a terrifying contradiction. When scientists use the Saturn orbiting Cassini probe as a cosmic scale, measuring the tiny gravitational perturbations the belt exerted on the ringed planet, they found something that shouldn't be possible. Based on everything we know about how solar systems form, there should be 20, 30, maybe even 50 Earth masses of material out there. It should be a dense, crowded highway of ice giants in the making. Instead, the total mass of the entire Kuiper Belt is only 1/16 that of the Earth. 99% of the material is gone. It has vanished. Where did it go? Did a migrating Neptune act as a cosmic bulldozer, screaming through the region and scattering the building blocks of planets like dust in the wind? Or are we looking at the ruins of a much more grandiose structure that was decimated by an event we still don't understand? The current belt isn't the original structure, it is a pale ghost, a shadow of what used to be. And yet, even as a shadow, it is performing a dance that defies the laws of physics as we know them. In 2017, researchers discovered that the Kuiper Belt isn't a flat disk. In its outer reaches, the average plane of the belt begins to tilt and warp, deviating by more than 9 degrees from the rest of the solar system. Even more haunting is the discovery that this warp isn't static. The entire structure precesses, it wobbles, with a rhythmic period of 1.9 million years. To an outside observer, the entire Kuiper Belt would look as though it is slowly breathing. This isn't the behavior of a dead graveyard, it is the behavior of a structure being manipulated by an invisible hand. The standard explanation for this breathing is the gravity of the known planets, but the math doesn't quite add up. The warp is too extreme, the rhythm too precise. It suggests that there is a missing sculptor hiding in the dark, a mass the size of Mars, or perhaps even an Earth mass super-Earth that is pulling the strings of the belt from the shadows. We are scouring these outermost regions, hoping to discover a new mystery, yet finding that the more we look, the more the edge of the solar system seems to retreat. As we move deeper into this documentary, we have to ask ourselves, is the Kuiper Belt truly where the solar system ends, or is it merely the first layer of a much larger, more complex shroud? We are finding that this region isn't just home to short-period comets like Halley's, and it isn't just a collection of leftovers. It is a dynamic living frontier. We see objects like Makemake emitting methane into space, and Quasar showing signs of rejuvenated crystalline ice, processes that should be impossible for dead rocks so far from the sun's warmth. We are standing on an invisible threshold. To our ancestors, the edge of the world was the horizon. To the astronomers of the 1980s, it was the orbit of Neptune. But as we look at the warped, breathing, and decimated ruins of the Kuiper Belt, we realize that we are just beginning to understand the true scale of our home. We aren't just looking at the end of the solar system, we are looking at a boundary of knowledge, a physical limit to what we can see, but not to what is actually there. In the chapters to come, we will peel back the layers of this cosmic archive, from the dual populations that shouldn't be overlapping, to the Kuiper Cliff where the universe seemingly stops dead, and the invisible puppeteer that might be lurking just beyond the reach of our greatest telescopes. The edge is not a destination, it is a mask, and it's time we look behind it. Imagine walking into a library that should, by all laws of physics and history, be filled with tens of thousands of volumes, only to find a single torn page lying on a dusty floor. This is the staggering reality astronomers faced when they first tried to weigh the edge of our solar system. According to every model of planetary formation we possess, the Kuiper Belt should be a bustling, crowded metropolis of ice and rock. The math of our sun's birth is uncompromising. There should be 20, 30, perhaps even 50 Earth's worth of material orbiting in that distant ring. It should be a dense, heavy reservoir of potential planets that never quite cross the finish line. But when we actually put the Kuiper Belt on a scale, the results were chilling. To weigh something billions of miles away, scientists didn't use a telescope. They used a planet. By tracking the Saturn orbiting Cassini spacecraft with an accuracy of just 1 meter, researchers were able to measure the tiny, almost imperceptible gravitational tugs that the outer belt exerted on the ringed giant. They expected to find a massive influence. Instead, they found a ghost. The entire mass of everything we can see beyond Neptune, every dwarf planet, every icy moon, every wandering comet, doesn't even add up to 1/16 of the Earth. It is barely 5 times the mass of our moon. This isn't just a rounding error, it is a cosmic void screaming for explanations. 99% of the material that should be there has vanished into the dark. This discovery transformed our understanding of the Kuiper Belt from a simple collection of leftovers into a crime scene. We are looking at a decimated ruin, a pale ghost of a much more grandiose structure that was systematically dismantled during the solar system's violent childhood. Somewhere in the deep past, a cataclysmic event took place that cleared the slate, leaving us with only the wreckage. To find the culprit, we have to look at the orchestra director of the outer system, the blue giant, Neptune. For eons, we imagined the planets as permanent fixtures, born and raised in the orbits they occupy today. But we now know that the early solar system was a place of terrifying instability. During a period of gravitational chaos, Neptune didn't stay put. It migrated outward, pushed by the massive influence of Jupiter and Saturn as they settled into their own rhythmic dances. As Neptune moved, it didn't just drift, it acted as a cosmic bulldozer. It plowed through the original dense disk of icy planetesimals, the building blocks of worlds. It was a gravitational massacre. Millions of objects were caught in its wake and flung inward toward the sun to be incinerated, while others were hurled outward into the interstellar void, lost to the galaxy forever. The objects we see today in the Kuiper Belt are not the norm. They are the lucky survivors, the refugees of a planetary migration that nearly wiped this region of space clean. And yet the destruction didn't end with Neptune's migration. Even today, a slower, more insidious process called the collisional cascade is grinding the belt into nothingness. The Kuiper Belt is essentially a slow-motion demolition derby. Because the objects are so far apart and moving in such wide, tilted orbits, their impacts aren't gentle mergers that build planets. They are high-speed collisions that shatter ice into microscopic dust. This dust is then caught by the solar wind and radiation pressure, blown out of the solar system like smoke in a breeze. The belt is literally self-destructing, grinding its members into a powder that is then dispersed into the void. When we compare our solar system to others, the mystery of our missing mass becomes even more haunting. We've looked at other stars, Vega, Fomalhaut, and Epsilon Eridani, and found that they possess massive, brilliant disks of debris that extend for hundreds of astronomical units. Compared to these vibrant, heavy rings, our Kuiper Belt appears strangely small and poor in material. We are the poor, decimated version of what a planetary system should be. We are living in a solar system that has been stripped of its outer wealth, but there are fossils hidden in the belt that prove it wasn't always this way. One of the most bizarre findings from our recent missions is the existence of ultra-wide binaries, pairs of objects that orbit each other at staggering distances, some separated by over 65,000 miles. These pairs are so delicately bound that a single gravitational nudge should have torn them apart millions of years ago, yet they have survived for 4 billion years. These binaries are fossils from an era when the belt was dense and velocities were low. They are the silent witnesses to a time before the bulldozer arrived, before the mass vanished, and before the solar system's edge became a graveyard. As we stand on this cosmic shoreline and look at the ruins, we are forced to ask, if the bulldozer was thorough enough to remove 99% of the mass, why did it leave these delicate binaries behind? And more importantly, Why is the remaining mass, this 1/16th of an Earth, suddenly and violently dropping off at an invisible line called the Kuiper Cliff? If the mass is gone, where did the invisible sculptor go after it finished its work? We are finding that the void is not empty because of a lack of material, but because something is still out there, shaping the shadows. In the next chapter, we will look at the rhythm of the belt itself, the strange 1.9 million year breath that suggests the solar system's edge is being manipulated by a force we have yet to see. For generations, our mental image of the solar system has been one of elegant, flat geometry, a series of concentric circles laid out like the grooves on a vinyl record. From the scorched rock of Mercury to the frozen winds of Neptune, everything seems to follow a strict, orderly plane called the ecliptic. It is the level ground of our cosmic neighborhood. But as we move past the orbit of the 8th planet and into the deep freeze of the Kuiper Belt, that order doesn't just fray, it breaks. We are discovering that the edge of our solar system isn't a flat disk at all. It is a warped, twisted, and rhythmic structure that behaves less like a collection of rocks and more like a living, breathing entity. In 2017, 2 astronomers from the University of Arizona, Catherine Volk and Renu Malhotra, decided to look at the levelness of the outer solar system. They analyzed the orbital inclinations of over 600 objects scattered throughout the Kuiper Belt, expecting to find the same boring flat alignment we see in the inner planets. For the first 50 astronomical units, the data behaved perfectly. The belt lay almost perfectly flat, tilted by a negligible 1.8 degrees. But then they crossed the 50 AU threshold, the region we've come to call the Kuiper Cliff, and the map went wild. Beyond 50 AU, the average plane of the Kuiper Belt begins to tilt and warp, progressively deviating until it is slanted by more than 9 degrees. To put that in perspective, a 9-degree tilt in orbital mechanics is a massive structural anomaly. It's the astronomical equivalent of walking down a perfectly level hallway and suddenly finding that the floor has turned into a steep ramp. This isn't just a few rogue rocks out of place. It is the entire classical belt being pulled out of alignment. This discovery was so startling that researchers calculated the probability of it being a statistical error. The result? Only 1 or 2%. The warp is real. The edge of our world is bent. But why? What force is powerful enough to twist a 1 trillion-mile-wide ring of ice? The traditional orchestra directors of the solar system, Jupiter, Saturn, Uranus, and Neptune, simply aren't strong enough at these distances to cause a 9-degree warp. Their gravitational reach begins to thin out, leaving the outer belt to its own devices. This led Volk and Malhotra to a chilling conclusion. There is an invisible sculptor hiding in the dark. To cause a warp of this magnitude, there would likely need to be an object with the mass of Mars orbiting at roughly 60 astronomical units from the Sun. This isn't the distant, massive Planet 9 we often hear about. This is something closer, smaller, and even more elusive. It is a planetary mass object that has been silently bending the solar system's edge for billions of years, remaining completely undetected by our most powerful telescopes. However, the mystery goes even deeper than a simple tilt. This warp isn't a permanent frozen feature. By running complex simulations based on the movement of these distant icy bodies, scientists realize that the entire plane of the Kuiper Belt is precessing. It is wobbling. The entire structure rotates in a slow rhythmic cycle with a period of 1.9 million years. When you step back and look at the solar system on a geological timescale, the Kuiper Belt appears to be breathing. Imagine a giant translucent donut surrounding our sun, slowly rising and falling, twisting and flexing in a nearly 2 million-year heartbeat. This breathing plane challenges the very idea of a dead graveyard at the edge of space. It suggests a level of dynamic, rhythmic activity that we usually only associate with living systems or complex machinery. If the belt is breathing, we have to ask, what is the heart? What is the source of this rhythm? If it isn't a hidden Mars-sized planet, the only other explanation is even more haunting. Some scientists suggest this warp could be the gravitational scar of a passing star. In the first few million years of our solar system's life, we weren't alone. We were born in a crowded stellar nursery, and it's possible that a neighboring sun screamed past our own, coming close enough to catch the edge of our protoplanetary disk in its gravitational wake. If this theory is correct, the 9-degree warp we see today is a 4-billion-year-old bruise, a memory of a cosmic near collision that permanently disfigured the shape of our home. This realization transforms the Kuiper Belt from a belt into a donut of chaos. Most people imagine the belt as a thin ring, similar to Saturn's rings, but because of the hot population of objects, those with orbits inclined by as much as 30 degrees, the structure is actually thousands of times thicker than the asteroid belt. It is a massive three-dimensional shroud, and yet within this shroud, we find the cold population, the objects that have stayed in nearly circular flat orbits for the entire history of the solar system. These two groups are overlapping, sharing the same space, but dancing to completely different tunes. The cold population represents the original undisturbed material of the solar nebula, while the hot population consists of the refugees, objects that were kicked out of the inner system and forced into these high inclination dance moves. The fact that these two populations can exist in the same space without having completely destroyed each other or merged over 4 billion years is a testament to the sheer scale of the void. They are like two different ghost stories being told in the same room, each unaware of the other. As we look out at this warped, breathing donut, we have to confront a difficult truth. We have spent centuries perfecting our maps of the flat solar system, only to realize that the most massive structure in our neighborhood is a twisted, wobbling enigma. The Kuiper Belt is the cosmic archive we discussed in the previous chapters, but it isn't just recording what happened. It is reacting to what is happening right now. It is responding to the gravity of unseen planets or the lingering ghosts of dead stars. The edge of the solar system isn't a static boundary where the real planets end and the junk begins. It is a frontier that is actively being shaped and reshaped by forces we are only just beginning to name. We call it a cliff because the objects seem to disappear at 50 astronomical units. But perhaps the objects aren't disappearing at all. Perhaps they are simply following the warp, diving into the dark where our current telescopes can't follow the curve. In the next chapter, we're going to look at the residents of this warped plane, the hot and cold tribes, and the dual Kuiper Belt theory that suggests our solar system might actually have two edges, overlapping in a way that defies everything we thought we knew about our origins. Within the heart of the Kuiper Belt, in a narrow band between 42 and 45 astronomical units from the Sun, lies a region astronomers call the classical belt. On a map, it looks like a single unified structure. But if you were to look at the motion of the objects themselves, you would realize you were standing in a celestial meeting ground for two groups of travelers that have absolutely nothing in common. These are the hot and cold populations, and the fact that they occupy the same space is one of the most significant clues we have to the solar system's violent, fragmented past. To be clear, these names have nothing to do with temperature. In the Kuiper Belt, everything is frozen to the core. Instead, hot and cold refer to their orbital velocities, an analogy borrowed from the way gas particles behave when they are energized. The cold population consists of the solar system's original inhabitants. These objects follow nearly perfect circular orbits, staying flat and relaxed within the plane of the planets, never tilting more than 10 degrees. They are the calm ones, the survivors who have stayed in their lane for 4 billion years. But the hot population is doing something entirely different. These objects are the Kuiper with cool dance moves. Their orbits are stretched into ellipses and tilted by as much as 30 degrees or more. They are energetic, chaotic, and seemingly out of place. It's as if you walked into a library and found half the patrons sitting quietly in chairs while the other half were sprinting across the tables. They are in the same room, but they are living in two completely different realities. This leads us to the dual Kuiper Belt theory, a concept that suggests these two tribes represent two entirely different eras of history. The cold objects are the indigenous residents of the solar system's edge, primordial fossils that formed exactly where we find them today. We know this because of the ultra-wide binaries found among them, like the pair named Antipholus and Antipholus. These are two identical twins, each 62 miles wide, orbiting each other at a staggering distance of 65,000 miles. They are so delicately bound that their orbital speed is a mere 7 miles per hour. If anything, a passing planet, a stray rock, a gravitational nudge had ever disturbed them, they would have drifted apart millions of years ago. Their existence is a miracle. It proves that the cold region has been a place of eerie, low-velocity silence since the dawn of time. But then, the hot population arrived. These were the refugees, objects that were born much closer to the sun, near the original orbits of the gas giants. When Neptune began its cosmic bulldozer migration, it didn't just destroy the belt, it acted as a gravitational catapult, flinging these hot objects outward and dumping them into the stable, cold region. The mystery that keeps astronomers awake at night is how these two populations can overlap without the hot intruders destroying the delicate, cold fossils. It suggests that the solar system didn't just form once, it was reshaped in distinct overlapping waves. We aren't looking at one belt, but two separate stories of creation and exile that happen to share the same coordinates in the dark. As we peel back the layers of these overlapping tribes, we start to see that the Kuiper Belt isn't just a ring of debris, it's a crossroads. And as we're about to see in the next chapter, some of the residents of this crossroads didn't stay there. They were captured, turned into gravitational trophies that we now call moons. If the Kuiper Belt is a vast frozen library containing the original blueprints of our solar system, then the giant planets are the ancient thieves who broke in and made off with the most precious volumes. For decades, we looked at the moons of the outer solar system as loyal companions that formed alongside their parent planets. But as our probes began to taste these worlds, we realized we weren't looking at siblings. We were looking at prisoners. In the violent, dynamical history of our neighborhood, the Kuiper Belt didn't just sit at the edge, it donated some of its finest pieces to the gas giants. The most staggering example of this celestial heist is Triton, Neptune's largest moon. At 1,680 miles wide, it is the 7th largest satellite in the solar system, actually dwarfing Pluto in size. But Triton carries a dark secret in its motion. It orbits Neptune backward. While every other major moon in the system follows a prograde path, spinning in harmony with its planet's rotation, Triton moves in a retrograde orbit. This is the smoking gun of a cosmic kidnapping. It is physically impossible for a moon of this scale to form backward from the same dust cloud as its planet. Triton was almost certainly a massive Kuiper Belt object, perhaps even part of a binary system like Pluto and Charon, that wandered too close to Neptune's gravitational snare. When Voyager 2 streaked past Triton in 1989, it revealed a world that was essentially Pluto's long-lost twin. The density, the surface nitrogen, and the presence of methane and carbon monoxide ices are nearly identical to what we find on the king of the Kuiper Belt. But Triton is more than just a frozen rock. It is a living witness to active geology. Voyager captured images of giant geysers erupting from a subsurface ocean, shooting plumes of dark, sooty material and liquid nitrogen 5 miles into a thin, tenuous atmosphere. By studying Triton, we are essentially performing a proxy mission to the deep Kuiper Belt without having to travel the extra billions of miles to get there. Neptune isn't the only planet with a trophy room. Saturn has its own captured ambassador, Phoebe. Discovered in 1899 and visited by the Cassini probe in 2004, Phoebe is another retrograde rogue that orbits on a strangely inclined path. While most of Saturn's moons are bright and icy, Phoebe is a dark, scarred world rich in organic materials and water ice. It is a chemical fingerprint of the Kuiper Belt, a displaced fragment that escaped the edge and became a permanent resident of the ringed planet's kingdom. In fact, the more we look at the gas giants, the more we realize they are surrounded by these gravitational trophies. Jupiter, Saturn, Uranus, and Neptune are all orbited by dozens of irregular satellites, small moons on chaotic tilted paths that were likely snatched from the Kuiper Belt or the scattered disk during the solar system's chaotic youth. These objects are frozen ambassadors, pieces of the outermost realm that took an epic journey across the system to end up in the service of the giants. Every time we study them, we are peering through a keyhole into the true nature of the belt. They remind us that the edge of the solar system isn't just a distant place. It is a force that has left its mark on every world we have ever explored. In the next chapter, we will look at the bizarre fossils these ambassadors left behind, binary systems that are either touching or drifting, with a missing middle that defies every law of orbital stability. When the New Horizons spacecraft beamed back the first clear images of Arrokoth in 2019, the world saw what looked like a primitive reddish snowman drifting in the dark. But to astronomers, this wasn't just a mascot, it was a physical impossibility. Arrokoth is a contact binary, composed of two lobes that fuse together at a speed of only 2.2 miles per hour. These massive objects collided at the walking speed of a human, a gentle touch that would be impossible in the high-velocity chaos of the inner solar system. This delicate union is our first piece of evidence that the Kuiper Belt is a place where time and physics operate differently. In the cold classical region of the belt, nearly 30% of all objects are found in binary pairs. This is a remarkably high frequency, but the real mystery lies in the spacing of these partners. Binaries here exist only in two extreme configurations. They are either super tight and touching like Arrokoth, or they are super wide, separated by distances that should be gravitationally impossible to maintain. There is almost nothing in between. This is the missing middle, a structural gap that suggests the Kuiper Belt is a binary desert where intermediate separations simply cannot survive. The most extreme example of this long-distance relationship is the pair known as 2001, QW322, affectionately named Antipholus and Antipholus by the astronomers who tracked them for 7 years. These two ice worlds are identical in size, yet they orbit each other at a staggering distance of 65,000 miles. To put that in perspective, they are separated by a distance equivalent to more than 8 Earth diameters, yet they are held together by a gravitational bond so weak they only move at 6.7 miles per hour. A single tug from a distant planet should have severed this bond billions of years ago. Yet they have endured, performing a glacial dance that takes nearly 30 years to complete a single orbit. Scientists believe these objects are binary fossils, pristine remnants of the solar system's original construction phase. They are the evidence of a primordial era when the belt was far denser and the velocities were incredibly low. These fossils survived because they were tucked away in a region of space that Neptune's cosmic bulldozer never quite reached. While the rest of the solar system was being hammered by high-speed collisions and planetary migrations, these twins remained in a state of eerie, frozen silence. However, this silence is not permanent. Today, the belt is undergoing a collisional cascade, a slow-motion demolition derby where objects fragment into smaller and smaller pieces. This process is grinding our fossils into microscopic dust that the solar wind eventually sweeps away into the interstellar void. The Kuiper Belt is essentially a self-consuming graveyard, and every wide binary that drifts apart is a page of history being torn out of the book. As we look beyond these fragile twins toward the very edge of the belt, we encounter the most terrifying anomaly of all. It is a place where the objects don't just thin out, they stop dead. In the next chapter, we will confront the Kuiper Cliff, the invisible wall at 50 astronomical units that suggests the solar system doesn't just end, it has been cut off. As we sail past the 50 astronomical unit mark, we aren't just entering the deep dark. We are approaching a structural anomaly that seems to defy the very logic of how stars are born. In almost every other debris disk we've observed around distant stars, the material thins out gradually, like a fading mist that slowly yields to the interstellar vacuum. But in our own backyard, the solar system doesn't fade, it stops. This is the Kuiper Cliff, a sudden and violent drop-off in the density of objects, where the crowded, bustling highway of the Kuiper Belt suddenly becomes a ghost town. Scientists expected the belt to continue for hundreds of units, yet at precisely 50 astronomical units, the number of detectable objects plummets so drastically, it's as if they've been wiped from existence by an invisible hand. This isn't just a minor statistical dip, it is a cosmic void screaming for explanations that challenges our entire model of how the sun's protoplanetary disk was constructed. For years, the most comfortable explanation was observational bias, the idea that objects beyond 50 astronomical units are simply too small, too dark, or too far away for our current telescopes to catch. But as our technology has improved, allowing us to find tiny pinkish worlds like Farut and Farfarout at distances of 120 and 140 astronomical units, the silence at the 50 AU mark has only grown louder. If we can see a 500-kilometer rock over 10 billion miles away, why is the region just past Neptune so strangely empty? The cliff suggests that the solar system didn't just run out of material, it was truncated. One leading scientific theory posits that, in the solar system's infancy, a passing star screamed through our neighborhood, coming close enough to physically strip away the outer edges of our birth disk. This stellar flyby would have acted like a cosmic blade, shearing off the material that should have formed a massive extended belt and leaving us with the poor, decimated version of a planetary system we see today. However, there is another, perhaps more unsettling possibility: the missing sculptor. To create a boundary this sharp, many astronomers believe there must be a planetary body the size of Earth or Mars, lurking just beyond the cliff, acting as a gravitational shepherd. This hypothetical world wouldn't just be sitting there, it would be actively sweeping the region, vacuuming up debris and maintaining the sharp boundaries we observe. This isn't the distant 10 Earth mass Planet 9, but a closer, more elusive shepherding planet that exerts a shaping influence akin to Neptune, but from the shadows of the 50 astronomical unit line. This brings us to the most provocative idea found in the lore vault, the concept of the cosmic wall, or an artificial boundary. While mainstream science looks for hidden planets or passing stars, fringe theories suggest the Kuiper Cliff might be evidence of an external force or a structural limit we don't yet understand. Is it possible that the cliff is not a natural end, but a barrier? Or perhaps, as we discussed with the breathing plane, the objects aren't gone, but have been warped so severely into the dark that we are simply looking in the wrong place. As we stand on the edge of this precipice, we realize that the solar system doesn't end with a whimper, it ends with a wall. And as we're about to discover, the true master of this wall might be a massive, invisible puppeteer that has been hiding in plain sight for billions of years. For centuries, we believed that the movement of the planets was a solved equation, a grand clockwork masterpiece where every gear was accounted for. But as we push deeper into the Kuiper Belt, we are discovering that the clock is being tampered with. There's a ghost in the machine. In the cold, silent reaches of the outer solar system, astronomers have noticed something that shouldn't be happening. The most distant objects we can track, the extreme trans-Neptunian objects, are not moving randomly. Instead, their orbits are clustered, lining up in a single direction, as if they are all being herded by an invisible shepherd. This kind of alignment almost never happens by chance. It is the smoking gun of a massive, unseen gravitational force, an invisible puppeteer pulling the strings of the solar system's edge. This mystery brings us to the hunt for Planet 9. We've been here before. In 1846, the planet Neptune was discovered not by a telescope, but by mathematics, as astronomers realized its gravity was pulling the orbit of Uranus out of line. Today we see the same unnatural behavior in the Kuiper Belt. Mathematical modeling and complex computer simulations suggest that for these orbits to line up the way they do, there must be a massive planet lurking in the dark, something between the size of Earth and Neptune, a super-Earth. Interestingly, these super-Earths are the most common type of planet found around other stars. Yet in our own backyard, this critical piece of the planetary puzzle appears to be missing. But finding this puppeteer is like looking for a needle in a haystack, where the needle is made of hay. If Planet 9 exists, it is likely 20 times farther from the Sun than Neptune, meaning the light it reflects is incredibly faint. To make matters worse, its predicted path takes it right through the most crowded, dense part of our sky, the heart of the Milky Way. Somewhere among those billions of fixed stars, a tiny dim speck is moving with a glacial orbit that takes between 10,000 and 20,000 years to complete a single trip around the Sun. However, Planet 9 might not be the only master of the shadows. As we discussed earlier, the strange warp in the Kuiper Belt's plane suggests a closer, more elusive sculptor. To explain why the belt suddenly tilts by 9 degrees beyond 50 astronomical units, some researchers believe there must be a planetary mass object the size of Mars, orbiting at roughly 60 astronomical units. This wouldn't be the giant Planet 9, but a smaller shepherding planet that maintains the sharp boundaries of the Kuiper Cliff and dictates the breathing rhythm of the belt's plane. If it isn't a hidden planet, the truth might be even more exotic. The lore vault points to the possibility of an undetected massive disk of objects, or even a hidden brown dwarf companion to our sun that has been manipulating the outer system for eons. Whether it is a super Earth hiding in the glare of the Milky Way, a Mars-sized shepherd at the edge of the cliff, or a vast dark disk of material, the evidence is undeniable. Something is out there. The Kuiper Belt is not a lawless frontier. It is a meticulously sculpted domain, and we are just beginning to see the silhouette of its ruler. But as we've seen, this region isn't just a place of shadow and gravity, it is a place of activity. In the next chapter, we will challenge the idea that this is a dead graveyard and reveal the surprising active geology that proves the edge of the solar system is still very much alive. For decades, we have looked at the Kuiper Belt as a cosmic morgue, a static, frozen repository of leftovers from the dawn of time. We imagined it as a place where the clock stopped 4.5 billion years ago, a silent shroud of ice and stone that does nothing but wait for the inevitable end. But as we look closer, we are finding that this graveyard is haunted. It is a structure that is simultaneously self-destructing and refusing to stay silent. This is the twilight era of the solar system, a phase where the boundary between a dead rock and a living world begins to blur in the deep freeze. On one hand, the Kuiper Belt is undeniably a place of death. It is caught in what scientists call a collisional cascade, a slow-motion demolition derby where the members of the belt are grinding each other into nothingness. Every time two of these icy bodies drift into one another, they don't always merge to create something new. More often, they shatter. These collisions produce fragments that Neptune's gravity eventually kicks toward the sun as comets, or they are ground into microscopic dust that the solar wind sweeps away into the interstellar void. It is a slow process of self-consumption. Year after year, the total mass of the belt decreases. In a few billion years, when our sun swells into a red giant, the Kuiper Belt may be completely gone, the last whisper of what was once an imposing, massive structure. Today we are merely looking at the pale ghost of its former glory. And yet within this living graveyard, we find worlds that defy the rules of a dead zone. Take Kuiper, a distant world that shows signs of crystalline water ice on its surface. To the average observer, ice is just ice, but to a scientist, crystalline ice is a revelation. In the extreme cold and radiation of the outer system, ice should naturally become amorphous, a disorganized glass-like state. For ice to be crystalline, it must have been heated and rejuvenated by recent geological processes. This suggests that even out here, where the sun is nothing more than a bright star, some hidden engine is keeping these worlds active. Then there is Makemake, which has been observed emitting methane into space, and Haumea, which possesses an impossible ring system that shouldn't exist according to classical physics. These are not static, dead bodies. They are worlds that continue to evolve, to change, and to respond to the forces acting upon them. They are in a twilight era where geological and collisional activity continues, but increasingly rarely and increasingly weakly. How can a world so small and so far from any significant heat source stay alive? Is it the lingering warmth of radioactive decay in their rocky cores? Or are they being manipulated by the tidal forces of unseen neighbors? We are realizing that the Kuiper Belt is not a static archive, but a recorder of catastrophes that is still writing its final chapters. It is a place that is barely, weakly alive, clinging to the last remnants of its primordial energy before it finally fades into the dark. But as we reach the very limit of this living graveyard, we find ourselves staring into a void that doesn't just mark the end of the belt, but the beginning of something much more vast. In our final chapter, we will step beyond the edge and into the Oort frontier, asking the ultimate question: where does the solar system truly end? We have reached the 50 astronomical unit mark, the point where the light of our sun is 1 billion times fainter than it appears on Earth, and the Kuiper Cliff has seemingly wiped the solar system clean. To the early pioneers of astronomy, this was the end of the world. But as we stand on this precipice looking out into the absolute black, we have to realize that the edge of the solar system is a moving target. What we have explored so far, the planets, the moons, and even the gargantuan ring of the Kuiper Belt, is merely the inner courtyard of a much larger, much more terrifying fortress. Beyond the cliff lies a mysterious realm of small rocky worlds and icy shadows that we are only just beginning to name. This is the frontier of the Oort cloud, the final shroud of our star. To understand where we are going, we first have to understand where we have been. In many respects, the Kuiper Belt is the end of the solar system, only in terms of physical objects that are currently reachable by our technology. It is a circumstellar disk extending from 30 to 50 astronomical units, a cosmic archive that recorded the catastrophes of our infancy. But the true edge is a matter of definition. If you define the solar system by the reach of the sun's magnetic field, the boundary is the heliosphere. In 2012 and 2018, the Voyager 1 and 2 probes, our farthest emissaries, passed this invisible milestone and touched interstellar space, the region where the solar wind finally gives way to the pressure of the galaxy. But if you define the solar system by the reach of the sun's gravity, the Voyagers haven't even left the front porch. Beyond the Kuiper Belt lies the scattered disk, a chaotic transition zone where objects have been flung into highly elliptical orbits that can take them hundreds of units away from the sun. This is home to worlds like Eris and the record-breaking Farfarout, a singular object situated at a staggering 140 astronomical units from the sun. These are the scouts of the deep remnants of the solar system's formation that provide a glimpse into the intricate dance of celestial bodies in the dark. But even Farfarout is a neighbor compared to what lies further out, stretching from the edge of the scattered disk to as far as 50,000 astronomical units, nearly a full light year from the sun, is the Oort cloud. Hypothesized by Jan Oort in 1950, this isn't a flat belt or a donut. It is a spherical swarm of trillions of icy bodies, a vast shell that completely encases the solar system. While the Kuiper Belt is clustered near the plane of the planets, Oort cloud objects arrive from any point in the sky, creating a truly three-dimensional shroud around our home. This is the point where the sun's gravity reaches the absolute end of its influence. This distant frontier is the true home of the comets. While short-period visitors like Halley's Comet originate in the Kuiper Belt, the long-period comets, those like Hale-Bopp that take thousands of years to complete a single orbit, come from the Oort cloud. These objects are the pristine fossils of our creation, held in a state of perfect preservation for over 4 billion years. But they also hint at something more substantial. Some astronomers postulate that the Oort cloud may be hiding more than just ice. It may be the final hiding place for the invisible puppeteer. While Planet 9 is often sought within the Kuiper Belt, there is an intriguing possibility that even larger bodies, Planet X or a hidden companion, could be concealed within the distant Oort cloud, influencing the orbits of the system from the ultimate shadows. As we look back from this interstellar frontier, our perspective on our home changes. We have discovered that our Kuiper Belt is strangely small and poor in material, compared to the massive debris disks around stars like Vega or Epsilon Eridani. We are looking at the ruins of a once far more grandiose structure, a solar system that has been decimated, warped, and sculpted by unseen forces. We have seen moons like Triton and Phoebe that were kidnapped from the edge and turned into gravitational trophies. And we have felt the 1.9 million year breath of a structure that refuses to be static. The Kuiper Belt was once a theory, a hypothesis that men like Gerard Kuiper didn't even believe would still exist today. Yet, it stands as a major part of our solar system in both a literal and figurative sense. It has reshaped our definitions, stripping Pluto of its status as a planet and forcing us to recognize a new class of dwarf planets like Haumea and Makemake. It has shown us that the apparent emptiness of the outer solar system was merely a failure of our own eyes. We are standing on a boundary of knowledge, not a boundary of space. The Kuiper Cliff may be a physical wall, or it may simply be a limit to what our current technology can perceive. As we move toward the mid-2030s, the Voyagers will eventually go silent, their fuel spent, and their missions ended, but they will continue to drift into the interstellar void as monuments to human exploration. They are the golden records of our curiosity, carrying 55 languages and the music of our planet into a universe that is far larger than our maps ever suggested. The edge of the solar system is not a destination, it is a mask. Behind the Kuiper Belt lies the Oort cloud, and behind the Oort cloud lies the vast beckoning dark of the galaxy. We are scouring these outermost regions not just to find new planets, but to find ourselves, to understand the needle in a haystack that is our own existence. We are a pale blue dot, caught in a beam of sunlight, protected by a gravitational bully like Jupiter, and surrounded by a living graveyard of ice. We may eventually mine these distant rocks or set up outpost stations on these frozen worlds, but for now, we are simply observers at the threshold. Each discovery in the Kuiper Belt and beyond raises deeper questions, suggesting that the true structure of our cosmic neighborhood is still hidden in the dark. The solar system doesn't end where the rocks stop. It ends where our curiosity does. And as long as we are looking into the shadows of the Kuiper Belt, searching for the invisible hand that warps the plane and herds the comets, the solar system will never truly end. It will only expand, a boundary of knowledge that we will continue to push, one icy mile at a time.